So, in the classical mechanics, today in this video, I will continue classical mechanics. Classical mechanics. So, in classical mechanics, how you will deal all the phenomena of classical mechanics. So, in the classical mechanics, there is three part. First is particle dynamics. Okay, particle dynamics. Okay, and after that arrow it is a similar kind of phenomena which include a lot of classical related, and this video is very much help you. Okay, and second point is system of particle. System of particle. Okay, second point is system of particle, and third point is rigid body dynamics. Rigid body dynamics. Rigid body dynamics. So in classical mechanics, in the particle dynamics, how you will concentrate it. Okay, and how you will learn. So particle dynamics, first thing is that number one is a center of mass. Center of mass. So what is center of mass? Center of mass is a point associated with every physical system. So let's say that central of mass is a physical system associated with every physical system. Okay, associated with every physical system whose motions and characteristics, whose motion and characteristics that of the system as the whole. That the system as whole. Okay, whole. And then the system moves under the external force of that point. So as a single particle would move under the same external force, so as uh, a particle, a single particle would move under the same external force, move under the same external force. Okay, move under the same external force. The motion of the system can be described. Motion of the system can be described. Okay, described in terms of the motion of mass. Terms of the motion of mass. Okay, in terms of the motions of mass, it will described. Okay, so let's consider a system of n particle. System of n particle of mass m1, m2, mn with position vector with position vector r1, r2, r3 rn relative to a fixed origin, relative to a fixed origin. Okay, so relative to a fixed origin, the position vector, so the position vector what will be মানে হচ্ছে r of cm, the center of mass of the system is center of mass of the system is center of the mass of the system of the particle is defined as r of cm in center of mass is equal to m1 r vector 1 plus m2 r2 plus m3 r3 uh, plus plus of mn rn, okay, divided by sorry divided by m1 plus 2 plus m3 plus plus of m to the power n. Okay, so in case of what, in case of summation of I is equal to 1 or n, so mi ri divided by summation of I is equal to 1 to n is equal to 1 by m summation of I is equal to 1 to n. Okay, so mi ri, where m is equal to summation of I is equal to 1 to n. Okay, at the same time mi, so this is total mass of the system, so this is the total mass of the system. This is the total mass of the system. Total mass of the system. So quantitatively r of cm represent geometric point, represent the geometric point. Okay, so represent the geometric point like located as the average position of the particle, position and the position. So for continuous distribution with the mass density of total energy arm become integral. So for the continuous মানে mass continuous of mass density and total mass m, okay, the sum becomes integral. So the sum become integral. So r is equal to 1 by m integration of r dm. Okay, so 1 by m integration of rho r dv is equal to integration of rho of r dv. Okay, divided by integration of row of r vector dv, where row stands density of the state, where row stands for the density of the state, for the density of the state. Okay, density of the state. Okay, and if an object has uniform density, then its center of the mass of the same, like centroid of its shape. It is if it has uniform density, like uniform density. Okay, uniform density, then it will be then all the particle all same. Okay, so the centered so after that the mass is the same of centroid. After that the mass of the field will be centroid. Okay, centroid, and of its shape, of its shape. Okay, so the following of two calculation may be drawn from above definition. So number one, if the mass of all particle is same, then what it will be? If the mass of all particles same, what all the mass of all particles same. Okay, mass of all particles same. Then then what it will be? Then what it will be? If the same particle is the mass of the same particle is same, then definitely it will follow that r of cm, and center of mass, radius of center of mass, m divided by is summation of I is equal to 1 to n r to the power n, equal to 1 by n summation of I is equal to 1 to n for r to the power 1, because m is equal to m n, n or m. This is the center of mass coincide with geometric center of mass. This is the center of mass coincide with geometric mass. Geometric mass. Okay, this is the coincide with geometric mass, and geometric mass. Okay, it is clear? And after that, the second point is that if the origin is at the center of mass, if the origin at the center of mass, if the origin is the center of mass, rcm is equal to 0, then summation of n to I is equal to 1 mi ri, okay, is equal to 0. The origin of the center of mass of rcm is equal to 0, then summation of I is equal to 1 and to n, also mi ri is equal to 0. So this is the sum of the moment of mass of the system about the center of mass is 0. This is the so this is the sum of the moments, sum of the moments geometric center of the system, geometric center of the system. Okay, So geometric center of the system. No. Yes, this is the system where geometric center of the mass systems is zero. Zero. Okay. Okay. So such as a center of mass is reference frame. So here I can say that center of mass is a reference phrase. So here such as center of mass reference frame. Center of mass reference frame. Center of mass is reference frame. A reference frame attached with the center of mass of the system of particle. Okay, a body is known as the center of mass C. So frame of reference. So C is the frame of reference. By the definition of this frame, the velocity of the center of mass is zero. So hence a linear momentum P of the system is 2. So given by P is equal to mv. P is equal to mv. So summation of mk and vk, okay, is equal to 0. The C frame of reference is therefore is also called the zero momentum of the frame, since the external force. So the central of the center of the mass and so the center of mass and hence the C frame, okay, with the constant velocity, and it is sorry. So sorry. So center of mass is coincide, okay. So after that uh, after that it will be the particularly useful to solving many problem which is difficult to solve to the laboratory and frame of reference, and indeed it has become that the customary to deal with the collisions on the nuclear physics in this frame of reference of alone, okay. So center of mass and the laboratory coordinates. What will be the center of mass and the laboratory coordinate? Center of mass and laboratory coordinate. Laboratory coordinate. What it will be? The center of mass and the laboratory coordinate will be what? No. Let's say this is x-axis. This is x-axis and this is y-axis, and this is a coordinate like this point to this point, and this point to this point. Okay, so this point. Okay, and from this point to this point, and this is also another point. This is m1. Sorry, this is m1, this is m2, and the distance between them is r2, and it is also r1, and the point is center of mass in cm, okay, and which is the radius of r radius, the center of r radius. So let us consider consider m and m1 and m2 we allocated mass by the vector of r1 and r2. We allocated mass by the radius vector. Mass by the radius vector r1 and r2. R1 and r2. Clear? And with the respect to the origin O. With the respect to the origin O. Okay, so with the respect to the origin O, so and this name is R2, this is R, and this is R1. Okay, and this is the origin name is O. So with respect to the origin O, okay, and it is clear here R1 and R2 called laboratory coordinates. Here R1 and R2, this R1 and this R1 is also called what? This is called laboratory coordinate. And further we can make respect to the center of mass by the radius R1 and R2. So further they can also be located with respect to the center of mass by radius of vector r1 and r2. These are called at center of mass of the coordinate. So further মানে radius vector r1 and r2 where these are called center of mass coordinate. These are called center of mass. These are called center of mass coordinate. Okay, so these are called center of mass coordinate. Okay, mass coordinate. So let r be the relative position vector, be the relative position relative uh, position vector in the center of mass is coordinate, and vector of center of mass in relative position vector. Okay, so r be the relative position vector in the center of mass coordinate, in the center of mass coordinate. Okay, position vector in the center of mass coordinate. Then let r vector be the relative position vector, be the relative position vector be the relative position vector. Okay, so r be the relative position vector. Center of mass in laboratory coordinate system will be, so the center of mass in the laboratory coordinate system will be coordinate system will be what distance coordinate system will be r is equal to r1 minus of r2 vector. So r vector will be r1 minus of r2 vector. Position of the particles of position vector position vector will be what? Now position vector will be जैसे कि r1 r2 and r and a particle of mass m1 and m2 and center of mass respective and center of mass respective. Okay, respective. So from so we know that r1 is equal to r1 vector minus of r vector is equal to m2 r divided by m1 plus of m2, which is nu divided by m1 into r vector, and r2 is equal to R2 is equal to what? 2 is equal to R2 vector minus of R is equal to M minus of M1 into R divided by M1 plus M2. So is equal to minus of nu of M2 into R vector. So where nu is equal to reduced mass, where nu is equal to what? Reduced mass. Okay, nu is equal to reduced mass. Is equal to M1 M2 divided by M1 plus of M2. M1 M2 divided by M1 plus M2. Okay. Therefore, the expansion for the velocities of the particles with the respect to the center of mass in terms of their own relative velocities will be what? So it will be R1 dot is equal to R1 dot vector minus of R vector. R dot vector is equal to nu divided by M1 R dot vector. Okay. So this will be and R2 vectors dot will be is equal to R2 dot minus of R vector. Okay. Is equal to it will be what? It will be nu divided by M2 into R vector, R dot vector, where R vector is equal to dr back divided by dt. Okay. Okay. The uniform velocity with the center of mass moves can be found. The uniform velocity with the which the center of mass moves. So the uniform velocity with velocity with which the center of mass uh, moves can be found. Moves can be found. Okay, moves can be found. So or it will be what? R minus of R. So it will be nu divided by M1 to R dot. Okay. So that R dot is equal to R1 minus of nu divided by M1 uh, into R dot vector. Okay. And after that, so at the same time it will be that R1 R dot 1 vector minus of M1 divided by M1 plus of M2. Okay. So into R1 dot plus of R2 dot. R2 dot. So for that case, what it will be? So after that it will be that R1 dot vector minus of M1 plus of M2 and minus M into R1 dot plus M2 into R2 dot and after that M1 plus of M2. Basically it is doing nothing, that it is a cross multiplication. Okay. So that's the main thing. Okay. Yeah, you understand that what is the main thing. Yeah, where nu is equal to what? Nu denoted reduced mass. Okay. Reduced mass. Reduced mass mane after that what it will be? No, it will be wait. Reduced mass will come later. So before reduced mass মানে okay. So M1 M2 so after that it will be that R divided by R M1 R dot 1 is equal to plus of M2 and R2 dot divided by M1 plus of M2. So this will be the ultimate thing. Okay. So relation between the different quantities laboratory and the system classical mechanics system, the center of mass in the system. Okay. Relation between in the different quantities and and center of mass system, what it will be. So the relation between different quantities. So the relation between different quantities and relative function, what it will be. So the relative system. So now we know obtain the relationship between the velocities of momentum, okay, and the scattering angles in the laboratory system. So classical mechanics, from already draw a figure here. Here you can see that from this figure, you can system that write that R1 is equal to, what we can write from above figure. We can write that R1 is equal to R plus of R1, okay, and R2 is also R plus of R2, okay, R vector plus of R2 vector. You can write it also, okay. And after that, the corresponding final velocities and the momenta are given by. So the final velocities and momentas are given by. So the final city and the momentum is given by what? So the final velocity and momentum will be given by that the v is equal to nu plus nu1, okay. So nu dot plus nu1, okay, v is equal to, and after that it will be nu plus of nu divided by m2 into r dot square. So here v is the velocity of center of mass of the system, where v is the city and the center of mass of the system, okay, where v is the velocity and the center of mass of the system, and v2 will be v plus of v dot 2, okay. So v2 will be v plus of v dot 2, it is clear. And after that it will be that nu is equal nu minus of v minus of nu divided by m2 r vector, clear. So after that momentum will be m1 v1 dot, okay. So for momentum will be m1 v1 plus m1 v1, okay, m1 v1 dot, okay, and is equal to m mv, okay, and plus of nu of r. So we also can obtain similar relation between initial velocities and momentum. We can also draw the similar relation. So we can also draw the similar relation, from where we can also delete the similar relation in where in the classical mechanics, okay, in the velocities of momentum. So the relation of the momentum of classical mechanics can be obtained from the from the above equation. So the relation between classical mechanics can be obtained from above equation, obtained from above equation, okay. So can be obtained from above equation. It is it is what it will be, m of new dot is equal to m1 b1 uh, into new b dot is equal to p1 plus of p2 is equal to k1 k2. And what is the k1 k2? K1 k2 is equal to the momentum. Okay, so action in external force, what it will be, the external of action of external force, it will be, I will discuss in later on. Okay, so this is it, this is going to end here.